Let's start blocking the animation of the bouncing ball. Here I still have my Bezier interpolation. So with all the keyframes selected, I will press T and switch to constant interpolation. This way our ball will snap on the different position we have previously set. The idea is not to get disturbed by any interpolation and focus on the timing and shapes of our ball. Since our animation will be cycling upon 24 frames, the frame 0 and the frame 24 will be exactly the same. So my timing will be a bit off if I read both frame 0 and frame 24. So I will reduce the length of my animation from frame 0 to frame 23. Talking about shape, we will sure now look at the squash and stretch. If you're into animation, I'm sure you already have heard about it. If you look for squash and stretch ball on YouTube, you may find this video. I put the link in the documentation. When the ball gets thrown at high speed on the surface and it touches it, it squashes. With the power of the impact, the ball gets flatter, but its volume has to be preserved, so it also gets larger. So in this case, squashing will bring to us two information: the power of the impact and the softness of the material of the ball. Regarding our animation, if we consider frame 0 to be the frame where our object will touch the ground, we can go like 1 or 2 frames forward and start squashing the ball by scaling it on the z-axis down, but also scaling it on the x and y axis up. This way we will have some volume preservation. You can see here that the keyframe hasn't been written as I need to enable the auto record. Since I haven't written any scaling keyframe previously, you can see that the ball remained flat. I will just press Alt S to reset the scale on the first frame and on all the other frames. As we have just created the scaling keyframes, they have just been added to our animation. And so by default, Blender will switch their interpolation to Bezier. So we can see that our location is still in step mode, but we have a scaling interpolation. So I will select all the keyframes, press T and set them to constant. From there we can work on the stretching of our ball. Stretching is physically less obvious when we are watching the tennis ball bouncing, but it's yet still here. So we can use stretching to input physical information to our bouncing ball, but we can also use it to input speed information. If we look at the very beginning of the video, we can see that the ball is blurry and it immediately translates to us some speed information. So while the ball is probably currently perfectly round, the way the camera is capturing it forms some kind of elliptic shapes. And we have the same feeling whenever we are watching something that goes fast. And if we watch the right hand of the scientist, we can see that his fingers are also blurred because his hand was moving very fast. It makes his finger looks a little larger and longer due to speed. When an object is falling and hitting the ground, it is at its maximum speed just before it hits the ground. On frame 0, we can input stretching information by scaling the ball up and reducing its scale on X and Y to preserve its volume. When the ball will leave the ground, it will also be its highest speed. So I can duplicate frame 0 and move it on frame 3 or frame 4. The ball stretch, hit the ground, squash, and stretch again when leaving the ground. Just by blocking those few frames, we start to have the feeling of the animation of the ball. And this is a very important input whenever we will be using the blocking method, is that you have to feel your animation just through those poses. As told before, frame 0 and frame 24 are supposed to be the same, so I will select frame 0, press Shift D to duplicate it and move it on frame 20. From frame 0 to frame 4, the ball is on the ground and then it's leaving the ground from frame 4 to frame 24. Timing-wise, the ball should travel upward and downward almost evenly. So I can offset the up position to frame 14. This way we have 10 frames moving upward and 10 frames moving downward. As a more subtle detail pass, what we can do is slightly squash the ball whenever it reaches its top position. This slight modification will translate the inertia of the ball whenever it's slowing down to its top position. Currently, our blocking is bringing the minimum information we need to go to the next step. All the extreme poses of the ball are keyed, and we have a rough timing. For this very specific exercise, it could be enough for me to go into spline, to go into the next step of the animation process. But we can also input some more details into the blocking stage by inputting some intermediate poses or in-betweens. The in-betweens will help us figuring out the spacing of our ball whenever it's in the air. Our ball is making a 8 meter high jump, so I will move it in between to 4 meter and I will clear the scaling. Now, depending on where I will move this keyframe, it will change the spacing of the animation. If I move this keyframe closer to frame 4 where it takes off, our spacing will be larger in the beginning of the jump than it is whenever it's reaching the highest point. Meaning that on frame 7, the ball will go faster than on frame 10, which is what we want. Because the ball is leaving the ground at full speed, so it will reach its mid-air position before frame 9. And when falling down, it will be at full speed on frame 24. So it should be mid-air, closer to frame 24 than frame 14. I know spacing can be a bit complicated when you are on the blocking stage, and it will be way more obvious in the next video. To summarize, during the blocking stage, we keyframe the extreme poses, we make a rough timing pass, we can use breakdowns and in-betweens to input more spacing and timing informations. We can use squash and stretch to input speed and physical information.